everyone, welcome back to my channel. Today let's try to solve another Leetcode problem. Problem number 17, letter combinations of a full number. So I will not write a dictionary here. If we see numbers 2 to 9, we have a dictionary of this number to a string ABC. I think everybody can write this. I will just explain two methods. So one is the recursive method, another is iterative method. Let me explain how can we use this kind of two methods to solve the problem first, and then I will code up from the environment from IDE here. Yeah. Now let me explain the iterative solution first. If we have two numbers, 2 and 3, if we use these two numbers, as we know, there are 9 combinations. It is A, B, A, E, A, F, D, B, D, B, E, B, F, and C, D, C, E, C, F. So basically, for the iterative solution, I will first define an array like this. Inside there is an empty string, and then I will use number 2. So there are 3 letters. I will put the 3 letters inside A, B, C. So this array will be updated to this array. So this will be the updated result. And then I will use number 3. So inside number 3, there are another 3 letters. So I will loop through one by one. D and A combine, and A and E, A and F combine, and similarly B and D, B and E, and B and F, and also for C and D, C and E, and C and F. So this is the iterative solution. Basically, we need to have 2 loops to loop through all of them. And before the 2 loops, we also need to find, we need 3 loops. The first loop, we need to find this digit, and then we need to go inside this digit to find this kind of this kind of let me see result, and then we need to combine this result with another letter. I will explain it clearly, I think, in the code to make it clear. And another way is use the iterative solution. We first need to define this backtracking function. The backtracking function will start from the 0. First we'll start from I, so I will start from 0, and current will be an empty string. So the condition is if the length of the current is equal to the length of the digits. So if 2 and 3, the length is 2. So if we have a letter combinations like A and D, the length equals to the digits 2, the length of the digits 2. So we can put our result. So the result for backtracking is an empty string. Put the result inside this empty string. So this A and D will go inside this empty string. So for this backtracking, we will track one by one until there's nothing we need to put inside. So how should we? So this is a condition for track, but how should we loop through it? So we need to track all the letters for the first loop. So for this letter C is the character inside this in this dictionary. So in the dictionary, so inside it is the digits. The digits inside it is I. So the I first will start from 0. If it start from 0, it is number 2. So inside number 2, it is ABC. So for this character, it's inside ABC. If it is inside, we can use backtracking. Backtracking inside will I plus 1, and backtracking inside will I plus 1, and here will be current plus this character C. I think I can make it clear to code it up. Now let's start it. First, we'll start from the iterative solution. So for the iterative solution, we will first define a string. Array inside it will be an empty string, and we will first check the digits first. So I will use n inside this digits. So for n inside digits, and inside digits there will be letters. The letters will be digits. Yeah. Mm, it will be dn. D is the dictionary. So here the letters will be, for example, if the number is 2, it will be A, B, C. And I also need to define a temporary array answers, because finally I will get my result. Result will be equal to these answers. So first of all, I will use a for loop for item in rest. So if anything is inside this result, if it is the previous numbers, like 2 and 3, the previous number is 2, it will ABC inside, and then I will use 3. 3 will be DEF. So for items inside this result, and for letters, so what is my letters currently? So my current letter is for C in letters. So for example, ABC already inside this result, there will be A, another one will be B, another one will C, and letters will be D, E, F, because here currently it is DN, it goes to number 3. So for C in letters, and answers just need to append all the results. So all the result will be item plus C, and from here I just need to result should equal to the answer. So result is equal to this answer. So for the first loop, result will be A, B, and C. For the second loop, it will compile with this number 3. And I can return my result. So here, for this, there's a condition we need to check it carefully. So if the digit is an empty string, the output is an empty array. It's not inside, put a empty string inside, not like this. So I have to make a check. Return result if digits. If there is some digits inside, I need to return the result directly. Otherwise, I need to return an empty array. Let's check if it is okay. Yeah, it seems okay. Let's just submit it. After that, I'll analyze the time complexity. Yeah, it seems okay, and I think it is faster than the recursive solution. Let's check later. Then let's analyze the time complexity first, because for iterative solution, it is easy to analyze because there are only 4 loops. So for n in digits, how many digits are there? Maybe 9. So it is a number of digits. So it is n, and for each number we press, for example 9, it is the longest length is 4. So how many numbers? It is 4 to the power of n. So the time complexity will be n times 4 to the power of n if I use Python. So this is the time complexity. But here, as we already use this result, so the space complexity will be also very large, I believe, because we need to put all the combinations inside. So how many combinations? For example, 2 and 3, 2 times 3. So the space complexity will be 4 to the power of n maximum. Actually, it is not, but for the max, it is 4 to the power of n. It seems it takes the space, but it is okay, because anyway we need to return the result. This result is what we need to return. So we only need to consider the time complexity. Now let's try another method. We will use backtracking recursive solution to solve it. So the result will be defined as an empty array, and here we use backtracking. And inside, we can first make it a path, and the backtracking will call backtracking. It will start from 0 and an empty string. So inside the backtracking is I for the index, and I will use current for the string. if the length of the current equals the digits n. So n I will define as the length of the digits. So if this length equals to n result, here we can use a result as a global variable because this will not change, only need to append one by one. Result will append this current. Now we need a return, otherwise it takes a little bit more time because current, if we already find one, we can return and continue to find another one. Now we need to use a for loop for character inside this inside this letters. For example, its letters is A, B, C. So how should we find it? So the digits I from 0, so the digits I from 0, it is 2, and from the dictionary, we use the dictionary, put the digits, put the string 2 inside, we get the ABC. So for C inside this ABC, we can use the backtrack directly. The first one will be, the I will be updated to I plus 1. So if this is a 2, so the next will be pointed to 3, and inside 3 there will be letters D, E, F. And the current will be, current is a string just plus this character C. So that's basically the entire code for the backtracking. As you can see, the backtracking is not so difficult. I think most of us can think of this solution, but we are not get used to the backtracking solution. We always use iterative. But when you compare, the backtrack actually is easier to think, because for iterative solutions there are 3 loops and you need to consider one by one. But for backtracking, if you grasp the template, so every problem is a template, and the difference is what is what result you need to find, what conditions you need to check when you find one result. So this is the difficult part. But for this problem, it is easier. But for other problem, when you try a lot of Leetcode problems, you might think this is also easier. And then for the backtracking, you need to consider the second part, how you will define this backtrack function, what variables will be inside, and how you will loop through for the next backtracking, find all the conditions. Yeah. Let me submit it to check if it really works. Yeah, now it works. The time, the speed is also okay compared with the iterative solution, and the time complexity is also the same. It is n times 4 to the power of n. Thank you for watching. See you next time. If you like my video, please like and subscribe. I will upload more Leetcode problem like backtracking, iterative.